Assalamu alaikum students. In this video we will be solving one problem related to free fall. As we agreed before that while solving problems related to free fall we will be applying the kinematic equations, the four equations of motion that we already memorized, all of us, but with some modifications. For the displacement we will be replacing delta x by delta y. And for the acceleration, we will replace it with g, which is the free fall acceleration, the special number, negative 9.81 meters per second squared if the problem is on Earth. Now for point 1, why we will be replacing delta x by delta y, it is because the free fall motion is motion on the y-axis or vertical motion. We will not be using the x-axis. The object can be dropped down or it can be thrown upward and then it will fall down. So we are working with the y-axis, vertical motion, vertical displacement. This is why we will be using delta y. And here you can see the four equations. Pause the video and write them with g instead of a and with delta y instead of delta x. Now the problem can be either a dropped object or an object that is thrown upward. For dropped objects, be careful that v initial must be 0. V initial must be 0 meters per second, because the object will be not moving at the beginning or at rest. And since it is a downward motion, delta y will be a negative number. If the object is thrown upwards, like here in this part of the photo, then keep in mind that v at the top will be equal to 0 meters per second. And in all, you should know that the acceleration is just g, which is negative 9.81 meters per second squared. This will not be given in the problem. You should add it to the given once you read the problem. Let us start here together. A flower pot falls from a window sill 25 meters above the sidewalk. So let me try to sketch it. Here is the flower pot, will fall down, and delta y will be negative 25 meters because it will be falling down and the downward direction is a negative direction. In A, we need to calculate how fast the flower pot will be moving when it strikes the ground. So on the side here, I'll record the givens. V initial will be 0 for any dropped object, and the acceleration will be g, negative 9.81 meters per second squared. Delta y will be negative 25 meters. So once we see the unit meters, this means this is displacement, and in free fall it's delta y. We need to find how fast means the velocity. So I have three givens and one unknown. I need to check which equation will be the best. You will find that this equation will be helping us to solve the problem in one step. So let us substitute v final squared is equal to v initial squared, which is 0 squared, so we can cross this term out. 2 times negative 9.81 times negative 25. Try it with your calculator. You will find that v final squared is 2 multiplied by negative 9.81 times negative 25. This will give us 490.5. And to find v final, as you all know, we need to take the square root of both sides. So v final will be 22.1 meters per second. Because this object is falling down and the downward direction is the negative direction all the time, we take the downward direction as negative direction in most of our problems. So this velocity actually is downward for direction, or negative. So either you write 22.1 meters per second downward or negative 22.1 meters per second. When they ask me how fast, they mean the speed only. So speed has no direction, it's a scalar quantity. And when they ask me how fast, okay, I need to not to consider the direction or the sign of the velocity. So the answer will be, for how fast, just the speed means no direction, so it will be 22.1 meters per second. Now in part B, they ask me how much time does a passerby on the sidewalk below have to move before the flower pot hits. So in part B, I'm asked to find delta t. If you take a look, I have V initial, I have G, I have delta y, and now I have V final as negative 22.1 meters per second. So I can use, for example, the first equation, V final equals V initial plus G delta t. V final negative 22.1. Be careful that in the four equations I keep the correct or I keep the signs because I'm dealing with vector quantities. 0 plus negative 9.8 1 delta t. So negative 22.1 is equal to negative 9.81 delta t. To find delta t, divide by 9.81, divide by 9.81. Delta t will be, you can pause the video and solve this one, 2.25 seconds. And this is the time needed for the flower pot to fall down. Please keep this sample problem on your notebook, as it will be helping you while solving the worksheet, inshallah. Thank you.